Hello and welcome to yet another video of Cornerstones of Math. This will be my last video of year 2023, and first I would like to thank you, my viewers, for watching my videos and supporting my work. In this very special video, I will prove that 123123 or 123,123 divides 2 to the power of 60 minus 1. Now before I proceed, I will explain some rules. First, it is obvious that this problem has something to do with the prime number factorization of this number. Here, I will just use this prime factorization result of 123,123 because explaining the entire process of obtaining this expression is not the main point of this video and is also boring. So I will just provide the result and use it. And secondly, we need to establish the rule regarding the usage of powers of 2. You see, we can just straight up compute powers like 2 to the power of 60 and use that value to show that this number is divisible by this number. That is at least theoretically valid proof, but we all know that simply using pre-known large numbers feels a bit cheesy. Therefore, I will set this limit. It seems that I can provide you the solution using powers of 2 that are only as high as 2 to the power of 10, which is 1024. So in my proof, I will not use any power of 2 that is larger than this upper limit, 1024. Now with that established, let us move on to the actual proof. Like I said, we must start from the prime factorization of 123,123. It is 3 times 7 times 11 times 13 times 41. So we have to find prime factors 3, 7, 11, 13, and 41 in 2 to the power of 60 minus 1. In order to do that, let us split this 2 to the power of 60 minus 1 into smaller numbers using the factorization skills we've learned in basic algebra courses. The first thing we can apply is famous square minus square factorization formula. Then we obtain 2 to the power of 30 plus 1 times 2 to the power of 30 minus 1. Then we can apply the factorization formulas for sum and difference of cubes. So from here, we have 2 to the power of 10 plus 1 times 2 to the power of 20 minus 2 to the power of 10 plus 1. And from here, we have 2 to the power of 10 minus 1 times 2 to the power of 20 plus 2 to the power of 10 plus 1. Here, notice that we can apply the difference between squares formula once more in 2 to the power of 10 minus 1, which gives 2 to the 5 minus 1 times 2 to the 5 plus 1. Now let's stop here for now and take a look at some of the smallest numbers first. So we have this, and starting from this, 2 to the power of 5 minus 1 equals 32 minus 1, which is 31, so there's nothing much we can do here. Next, 2 to the power of 5 plus 1 equals 32 plus 1 equals 33, which is 3 times 11. So we have confirmed that the prime factors 3 and 11, which are these, exist in 2 to the power of 60 minus 1. The next smallest number is 2 to the power of 10 plus 1. Here, using that 2 to the power of 10 is 1024. We have 1025, which is 5 times 205, which is 5 times 5 times 41. So we have found the prime factor 41, which leaves prime factors 7 and 13. Next, let us take a look at this one first, 2 to the power of 20 plus 2 to the power of 10 plus 1. This is not a smaller number compared to the other one, but the reason why I am looking this one first is because it is factorable. It is in the form of a to the power of 4 plus a squared b squared plus b to the power of 4, with a being 2 to the power of 5 and b being 1, which can be factored into a to the power of 4, and we split this a squared b squared into plus 2a squared b squared and minus a squared b squared. So this part gives a squared plus b squared squared. So this minus ab squared. So now we have squared minus square form. So we have a squared plus ab plus b squared times a squared minus ab plus b squared. So by applying this term is factored into 2 to the power of 10 plus 2 to the power of 5 plus 1 times 2 to the power of 10 minus 2 to the power of 5 plus 1. So it is 1024 plus 32 plus 1 times 1024 minus 32 plus 1, which is 1057 times 993. Here you can notice that 1057 is the product of 7 and 151. So we have found the prime factor 7. So all we have left is 13, but this 151 is a prime number, so it is no longer factorable. And for this 993, it is 3 times 331, and 331 is also a prime number, so 993 does not have 13 either. So we have to take a look at the last part, 2 to the power of 20 minus 2 to the power of 10 plus 1. Sadly, this one is not factorable into smaller powers, so we have to come up with another approach. Of course, we can simply calculate the value of 2 to the power of 20 using the value of 2 to the power of 10 and use this value to calculate this number. But as I said, I will not use the powers of 2 greater than 2 to the power of 10. So instead, let us write this number as 2 to the power of 10 times 2 to the power of 10 minus 1 plus 1. And use the value 1024, so we have 1024 times 1023 plus 1. And we investigate the remainders of these numbers when divided by 13. You can easily find that 1023 equals 13 times 78, then gives the remainder 9, and 1024 equals 13 times 78 plus the remainder 10. And let us use them. Then we have 13 times 78 plus 10 times 13 times 78 plus 9 plus 1. We expand this by considering this 13 times 78 as a single variable, such as a. Then the first part is just a plus 10 times a plus 9, which we can easily expand. So we have a squared, which is 13 squared times 78 squared, plus 19a, so 19 times 13 times 78, then plus 90 plus 1. So we have 91 here, and 91 equals 13 times 7. So we have 13 here, and 13 here. Therefore, 2 to the power of 20 minus 2 to the power of 10 plus 1 is divisible by 13, hence containing the prime factor 13. Therefore, to summarize, 2 to the power of 60 minus 1 has all of these prime factors, hence it is divisible by their products, which is 123,123. And that concludes the proof. So that was my last video of year 2023. Thank you all for watching and Happy New Year!